Okay, here we are, example number 2 in max and min. Find two positive numbers whose product is 100 and whose sum is a minimum. Okay, got it. So two numbers. Okay, we should always define our variables. So let's let x and y be two positive numbers. Okay, never a bad idea to define your variables, right? So it says two numbers whose product is 100. So x times y is 100, and whose sum is a minimum. So I want sum, and I want a minimum sum. And again, when I hear that, min or max, that tells me that's where I'm going to be taking my derivative to do my first derivative test. All right. Again, I need to isolate for x or y. It doesn't matter which one. So for no good reason, I'm just going to isolate for y. And now I sub that into my min sum. That's what I'm looking for. So I get x plus 100 over x, but I'm going to write it as x to the negative 1, right? Now I'm going to take the derivative of that with respect to x. So just take the prime of that like that. That's what we're going to do. And we're going to take the derivative with respect to x. So what do we get? We get our minimum sum. Oops, helps if you can write English, not my forte. Got our minimum sum. Okay, the derivative of this, well, that's going to be 1 minus 100 x to the negative 2. Now, we need to find our critical numbers here. Well, what I'm going to do before I find these critical numbers is I find it really easy here to, or at least it makes it easier, is probably the correct terms, to get a common denominator. All right, so this will be x squared minus 100 over x squared. Now I'm going to find our critical numbers. So let's switch to pretty pink. So what's our critical numbers? Again, our critical numbers are where that derivative is equal to 0 or the derivative does not exist. So in this case, well, the derivative doesn't exist when x is 0 because we'd have division by 0. So there's one. There's a critical number. The other one, when we set it equal to 0, we're going to end up having, if you want to factor it, you could have also have added 100 to both sides and then square rooted it. However you want to do it, friends, there's what you get from there. And again, x can't be 0. So we've got three critical numbers that we're going to check out here. Okay, so I go to do my sign analysis chart. But when I go to do that, here we go. So here's my sign analysis chart. And I say, okay, here's my three critical numbers. But thinking of my domain, the question said we had positive numbers. So negative 10 is actually outside my domain. So I'm not going to include it. And really, I'm not going to include 0 either. It's on the end point of 1. But I'm going to leave it there. So I'm really just going to check in between 0 and 10. So I'm going to do a test point of maybe, I don't know, 5. And I'm going to do a test point of, I don't know, 15. And again, where do we sub this information back into? It's always back into our first derivative. So where's our first derivative? Right here. Now notice the bottom will always be positive because it's being squared. So nothing to worry about there. So if I substitute 5 into the numerator, I'm going to get a negative. And if I substitute positive 15 in, that's 225 minus 100, that will be a positive. What do I have? Well, our sign analysis tells us we go from negative to positive. That means we go from decreasing to increasing. That tells me we have a minimum when x is equal to 5. Okay, well, we know that's one of our numbers. So now, oh, not when x is 5. Bad teacher, when x is 10. Oh, someone yelled at me there. Okay, well, now if we know what x is, let's go back and find y. And again, notice I boxed it right here. I always box that substitution so I can come back to it. So guess what? If x is 10, y is 10. And there's your two numbers. All right, hope that one helped.